you can calculate the probability for continuous data that follows a normal distribution. Just a reminder, a continuous distribution will be considered normal if it looks like a bell. And it also has to be symmetrical across the mean. So if your data is distributed like this, the probability that your data is under the curve is 100%. So that means the entire area under the curve is 1, or 100%. But if you want to know the probability of your data being in a different part of the curve, not just the whole thing, you have to use the z-score. And just a reminder, here's the formula for a z-score. It's x minus the mean divided by the standard deviation. And of course, I'm just using the notation for a population mean and a population standard deviation. I could use x bar for the sample mean or s for the sample standard deviation, and it means the same thing. So here's an example. Bolts are manufactured with a mean length of 55 millimeters and a standard deviation of 2 millimeters. We're going to assume that the length of the bolts is normally distributed. So if I were to think about how this would look as a probability distribution graph, I would have a normal distribution where the mean is 55 millimeters. So in the question, it's asking me to find the probability that a bolt will be shorter than 54 millimeters. Well, 54 millimeters is going to be on this side of mean. So the probability that a bolt will be shorter than 54 millimeters, I'm looking for the area under the curve just in this section. And now I'm going to calculate my z-score. So there's my formula. I'm going to plug in my numbers. So the value I'm interested in is 54 millimeters, so that's x. The mean is 55, and the standard deviation is 2. So when I do the calculation, I get a z-score of negative 0.5. So when I'm calculating my probability, I'm looking for the probability that the length is less than 54 millimeters. This is the same as the probability that the z-score is less than negative 0.5. So now at this point, I need to pull out my z-score table to figure out the corresponding area under the curve. So here's the z-score table, and it looks kind of complicated, but it's really not that bad. So what you have is the z-scores. So you have to find your corresponding z-score, and then the table tells you what the probability is for an area less than that on your normal distribution. So I'm going to zoom in a little bit here so you can see it better. In our question, we got a z-score of negative 0.5. So I need to find that z-score on my table. So I'm going to look in this column first, see if I can find negative 0.5. And there it is right there. So I'm going to look in this row. Now the second decimal in my z-score is 0. So that's this column. So what this means is for a z-score of negative 0.5, the area under the curve is 0.3085. This is the probability that we're looking for. So when I go back to my question, the probability that the length is less than 54 millimeters is the same as the probability that the z-score is less than negative 0.5. And I just used my z-score table to find that that was 0.3085. This means there is a 30.85% probability that the bolt will be less than 54 millimeters. So now we can ask a different question with the same situation. What is the probability that a bolt is longer than 59 millimeters? So this question's a little bit different because it's asking for when it's longer than 59 millimeters, not shorter. So in my normal distribution, 55 millimeters is the mean, 59 is on the right side of it, and it's asking for the probability that it's longer than 59 millimeters. So I'm actually looking for this area over here. And you just have to remember the Z-score table always gives areas for being less than a certain number. So if we want to know the probability that the length is greater than 59 millimeters, we need to rewrite that as 1 minus the probability that x is less than 59 millimeters. We're basically taking the complement. When I figure out my Z-score, I get a value of 2. So when I look at the second page of my Z-score table, I find there's 2, and it's 2.0 with no other decimals, so that's my probability right there, 0.9772. So I can plug that into my probability for 1 minus the probability that z is less than 2, so it's 1 minus 0.9772, which is 0.0228. So that means there's a 2.28% probability that the bolt will be longer than 59 millimeters. So the other type of problem you might have is figuring out the probability that your value is between two different numbers. So for the same bolt scenario, what is the probability that a bolt will be between 53 and 57 millimeters? So if I think about my normal distribution curve, I'm looking for that area between 53 and 57, which I write like this: the probability that x is between 53 and 57. So if I think about the probability that the length is less than 57, that's this entire area under the curve, and it goes back to the left. And the probability that x is less than 53 starts here and goes back to the left. So I really need to find out what's the probability that it's less than 57, and I need to take away the probability that it's less than 53. So I need to find the probability that the length is less than 57 and subtract the probability that the length is less than 53. And that will give me this area just in the middle, in between 53 and 57. And you can figure out the z-scores. I'll just do it for you. So a length of 57 has a z-score of 1, and the probability that the length is less than 53 millimeters is the probability that z is less than -1. So my z-score of 1 is here, so that's the probability that the z-score is less than 1. So the probability that z is less than 1 is 0.8413. And then I can look up the z-score of -1. So there's -1. There's my area. My probability is 0.1587. So now I can update this. The probability that z is less than -1 is 0.1587. And if I do the math, that's 0.6826. So there's a 68.26% probability that the bolt will be between 53 and 57 millimeters.